Hello everyone, hope you are good in health. As we have started discussion on occurrence of metals, let us learn how metals of high reactivity, medium reactivity and low reactivity are obtained from its ores. First of all, we'll learn extracting metals of low reactivity. For this, we will refer the last part of the summary chart, which is metals of low reactivity. So, first of all, you see, we will get sulfide ores. That means the metals will be in the sulfide ores form. That means, first of all, we will get sulfide of these metals. For example, HGS, that is cinnabar. Remember the pronunciation cinnabar. Cinnabar is an ore of mercury. So we get this HGS cinnabar. When this is heated in air, it is first converted into mercuric oxide, which is HgO. Okay, so this you need to remember. How it is obtained? First of all, we get cinnabar, which is ore of mercury. Then, first it is converted into mercuric oxide. Now, this mercuric oxide is reduced to mercury on further heating. You can see the chemical reactions. First it was 2HGS, that is cinnabar. In presence of oxygen, if we heat it, we get mercuric oxide HgO. And sulfur dioxide is released. Now, the HgO which we got, if we heat it further, we will get 2HgL. That is in the liquid form. Hg in bracket L, that shows liquid form. This way we get mercury. So this is about how we get mercury from its sulfide, then it is reduced to mercuric oxide, and then at last we get mercury. Similarly, copper, which is found as Cu2S, that is copper sulfide, in nature, and it can be obtained from its ore by just heating it in air. So this is copper sulfide ore. This is an ore of copper, that is Cu2S, copper sulfide. And how can we get copper from it? By just heating it in the presence of air. So here are the chemical reactions. 2Cus, that is copper sulfide, by heating in presence of air, that is oxygen, will get Cu2O, copper oxide, and then sulfur dioxide is released. And same way, Cu2O, that is copper oxide, plus Cu2S, that is copper sulfide, that gives us copper. Only just by heating it in presence of air. So this is about extracting metals low in the reactivity series. Let us talk about extracting metals of medium reactivity. For this, we will refer to the middle part of the summary chart. Metals of medium reactivity. Look at the summary chart. These metals are found as carbonate ore as well as sulfide ore. So in the nature, these metals are found in these two forms, carbonate ore and sulfide ore. What are carbonate ores and what are sulfide ores? We have learned about polyatomic ions in standard 9. There we learnt about carbonate also, sulfide also. carbonates are in the form of CO3 2 minus and sulfide, that is S2 minus. So the metals of this medium reactivity will be found as compound with these carbonates and sulfides. Then the carbonate ores will be done with calcination process, and sulfide ores will undergo roasting process. What are these processes? That we'll learn in detail. Then oxides of metals will be obtained, and then from this oxides reduction of metal will be done, and then purification. Let us see how it is done. The metals in the middle of the activity series, such as iron, zinc, lead, etc. These metals are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Please remember, it is easy to get the pure metal from its oxide than to get it from carbonates or sulfides. Therefore, prior to reduction, the metal, sulfides and carbonates need to be converted into metal oxides. So in whichever form we get the metals, whether it is in the carbonate form or in the sulfide form, what is to be done first? First, they are converted into oxide form. Why? Because to get metal from its oxide form, it is easy. That is why. So the sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. Remember the definition. What is roasting? The sulfide ores are converted into oxides. We have already learned that from sulfide it is needed to convert into oxide. So the sulfides ore are converted into oxides. How? By heating strongly in the presence of excess air. There will be huge amount of air, and this process is known as roasting. Now let us learn calcination. So, the carbonate ores are changed into oxide by heating strongly in limited air. This process is known as calcination. Let us refer to summary again. These two processes are very much easy, and it is very easy to remember also. Look, there are carbonate ores and there are sulfide ores. We know that the ores are first need to be converted into oxide form. For that, carbonate ores will undergo calcination process. What it is? Carbonate ores will be changed into oxides by heating strongly in limited air. This process is known as calcination. Okay, what is roasting? It is for sulfide ore. So sulfide ores are converted into oxides by heating strongly in the presence of excessive air. That is called roasting. Okay, it is easy to remember. What is the difference between calcination and roasting? Both are heating processes. Then what is the difference? For calcination, carbonate ores are converted into oxide, and the main point, in limited air. Remember this, for calcination, limited air is required. Whereas for roasting, sulfide ores are converted into oxide, and the main thing that excess air is needed for roasting. So this is the difference between calcination and roasting. Let us take an example for zinc. Zinc will be found as sulfide ore. So this is zinc sulfide ore, that is ZNS. It is zinc sulfide ore. Now recall the summary. Sulfide ores will undergo which process? Roasting. That is, they will be heated up in excess air. So there will be heat applied in presence of excess air, then it will be converted into what we know in the form of oxide, and as a product zinc oxide will be formed. Also sulfur dioxide gas will be released. So this is an example of roasting. Let us talk about now calcination. For that also we'll take example of zinc only. How zinc is obtained as carbonate ore. So in nature we get zinc carbonate ore. The formula for it is ZnCO3, zinc carbonate. What is calcination? Heating process in presence of limited air. So when this zinc carbonate ore is supplied heat strongly in limited air, then it turns into zinc oxide, ZnO, and carbon dioxide gas is released. So this way, these are the processes of roasting and calcination. After this metal oxide are reduced to the corresponding metal by using suitable reducing agent such as carbon. So here carbon is used for reducing this oxides. Now how is it so? Zinc oxide, that is ZnO. If we use carbon, that is C, then what happens? The carbon will form CO, that is carbon monoxide, and zinc will be separated. So this way we will get zinc. When zinc oxide is reacted with carbon, what will happen? Carbon will react with oxygen and it becomes CO, carbon monoxide, and zinc will be separated. So this way we will get metal zinc, right? Here you need to remember that carbon is used as reducing agent which will help to get metal from its metal oxide. For this we have also learnt oxidation and reduction processes in chapter 1. So obtaining metals from their compounds, that is also a reduction process, right? From compounds we are reducing it, that is reduction process.